Okay, so you know how much we love to dive deep into stuff that really makes you think, right? And this time, well, you guys sent us something that's definitely going to make us all scratch our heads a bit.
Yeah, it's
It's an excerpt, actually, called Time, the biggest misunderstanding in the universe.
wow, just the title alone makes you wonder, like, hold on, have I been missing something really big here?
Right, like something fundamental about how we understand the universe.
Exactly, and especially for you, the folks listening who really want to grasp these big, complex ideas, but also you want to do it quickly and thoroughly. That's what this deep dive is all about.
Yeah.
We're going to break down the core argument of this source.
Yeah, we're gonna get to the bottom of this, and
get ready, because it's going to challenge some stuff you probably take for granted.
Oh yeah,
like big time. The main idea is that what we experience as time, this thing we think is so fundamental, it might not actually be a force controlling everything in the universe.
Yeah.
It might be something else entirely.
Like we're talking about a whole different way of looking at it.
Totally different. It's saying that it's not that the universe has this invisible clock ticking away.
Right.
It's that the universe is, at its core, about motion.
It's all about motion.
Motion, yeah.
Yeah, and that's what we perceive as time. So we're going to get into this, and we're going to use everyday things.
Yeah.
That we all see, that we all experience.
The familiar stuff.
Yeah, but then we're going to go deep.
We're going to go deep, yeah.
Into some pretty heavy science to really kind of get those
aha moments.
Yeah, where things just
where it clicks.
Yeah, click into place.
And you see things in a totally new light.
A whole new way. Okay.
All right.
So the first part of this source really focuses on this idea that time is actually just motion and nothing more.
Mm-hmm.
And it starts with something we all use every day. A clock.
Yeah, like think about what a clock actually does.
Yeah, what's it doing?
It's showing us change, right?
Yeah.
The hands moving, the numbers flipping.
Yeah.
It's all about movement of some kind.
Right. It's got to be moving for it to be doing its job.
Right, exactly. And the source points out that a clock, it's not measuring this invisible thing called time.
Right.
It's tracking something much more concrete. Motion that's consistent and predictable.
Motion that we can count on.
That we can rely on.
Yeah.
So whether it's a quartz crystal oscillating or gears turning, the clock is really quantifying movement.
Right, so it's just measuring how much something's moving.
Exactly. And here's the kicker. Without that motion, the clock stops working.
Right, it's useless.
Useless.
It's just a thing.
It's a paperweight.
Yeah, it's a paperweight.
No movement, no ticking, no change on the display.
And according to this, no time being measured.
Right.
It makes you think, like, if absolutely nothing's happening, what's time even doing? It's like trying to measure something with the wrong tool.
Yeah, like using a ruler to weigh something.
Yeah, exactly.
It just doesn't work.
The tool's not made for it.
Right. And the source takes this idea even further to how we think about days and years.
Which seems so fundamental to time.
Yeah, like they're the building blocks of how we measure time, but they're not arbitrary units.
Right. They're tied to something physical.
The motion, yeah. Like a day is just the Earth spinning around.
Spinning on its axis, yeah.
And a year, that's the Earth going all the way around the sun.
Yeah, a full orbit.
A whole lap.
Yeah.
It's not about some independent time flowing by.
Right.
It's a direct result of things moving.
It's the mechanics. It's the way the universe is working.
It's how the cosmos works, yeah. And the article even says the Earth itself and the atoms inside it, they're forms of, get this, structured motion.
It's like motion built on motion.
Yeah, like inherent patterns of movement within them.
That's pretty mind-blowing.
It is. It is. And then there's aging.
Yeah, something we all experience and link to time.
Absolutely, but the source reframes even that.
Yeah,
they say your age isn't just time slipping away. It's actually a count of the motion cycles your body's gone through.
Like how many times you've gone around the sun.
Right, mostly those trips around the sun, which, by the way, set our seasons and a lot of our biological rhythms.
It's like our body's keeping track.
Yeah, it's like a cosmic counter.
Yeah.
And aging itself, biologically speaking, is a whole bunch of cellular processes.
Right, cells dividing and doing all their...
replicating, interacting, changing, all driven by motion.
Yeah, so it's motion at a microscopic level.
At the tiniest level.
Yeah.
And the article even suggests, and this is wild, that keeping your body's structured motion in sync might be the key to living longer.
So it's not about time running out. It's about how well our body's motion is coordinated.
Exactly, yeah. How well we're dancing, so to speak.
It's a whole different way to think about getting older.
It is, yeah.
It's not passive, it's active.
Yeah, you're not just along for the ride.
Yeah, you're part of the dance.
We're leading the dance.
Yeah, okay, so that's the everyday stuff.
The stuff we see all around.
Yeah, but the source uses some other examples too to kind of build up this argument. A little bit more complex, but still
Intermediate?
Yeah, like movies and video games.
Yeah, how do those fit into this idea of time as motion?
Well, they're all about creating the illusion of movement and time passing.
Right, and they don't do it with continuous motion.
Right.
They use a series of still images.
Right, those individual frames.
Each frame is like a frozen moment of motion.
And our brain puts it together.
Our brain fills in the gaps, stitches those moments together, and we perceive it as fluid movement.
Right, so we experience time even though it's really just a bunch of frozen bits of motion.
Exactly. It's our brains creating that experience.
It's like our brains are the time makers.
In a way, yeah, they're constructing that flow from static moments.
Yeah, pretty wild.
Yeah, and you can apply the same logic to something like a plant growing.
Right, we say it grows over time.
But the source says the growth itself is a result of all these chemical motions happening inside the plant cells.
So it's molecules interacting and cells dividing.
Exactly. It's all about motion at a microscopic level.
So the rate of growth isn't determined by some outside force of time?
It's not like time is pushing it along. It's determined by things like how much sunlight the plant gets and if it has enough water.
Which are both, when you think about it.
Which are also about motion, yeah.
Yeah, sunlight is photons moving and water is molecules moving.
It's all interconnected, all about motion.
So we're really starting to see a shift here, right?
Yeah, a big one.
Time isn't this stage where things happen. Motion is the thing happening.
It's the main event.
Yeah, and the source gets into some even more thought-provoking examples with water eroding rocks and wind erosion.
Yeah, those are great examples because they challenge how we think about time in relation to these really slow, gradual processes.
Processes that take, like, thousands or millions of years.
Right, eons.
So let's take water erosion. What's the traditional explanation for how that happens?
Well, the traditional view is that water slowly wears away at rock over a really long period.
It's like time is this patient sculptor.
Yeah, slowly carving out the landscape.
And we see canyons and smooth river stones and we think, wow, time is powerful.
Exactly, but the motion theory offers a completely different perspective.
Yeah, what does it say?
It says that both water and rock are different forms of structured motion.
Okay, so how does that explain erosion?
Well, think of rock as having very tightly synchronized motion.
Like all the particles are moving together in a very specific way.
Yeah, really stable. While water is more fluid, its motion is less rigid, less synchronized.
So when water flows over rock...
Right, the interaction between those moving water molecules and the rock disrupts the rock's tight synchronization.
And that causes it to break down.
Gradually, yeah. It's a constant interplay of motion.
So a smooth river stone isn't just about time passing.
It's a record of countless tiny interactions of water molecules jostling the rock's structure.
So it's not about time, it's about how much motion has interacted with the rock.
Exactly. Forget the slow grind of time. It's a dance of motion, a constant negotiation between different patterns of movement.
Yeah, that's a really subtle but important difference.
It is. It changes how you see the world.
And wind erosion, that kind of follows the same idea.
Absolutely. Air molecules are also structured motion.
Right.
And when they're moving really fast or carrying things like sand and dust,
which are also in motion.
Yeah, they can hit other materials and disrupt their structured motion, causing erosion.
So like a sandstorm.
Yeah, it's a dramatic example.
It can reshape things really quickly.
Right, it's a rapid display of motion's power.
So it's not time slowly wearing things down.
It's the intensity of the motion itself.
It's like, forget time, motion is the sculptor.
Exactly, it's the driving force.
Okay, so in all these examples, what we've thought of as time's effects can actually be explained by motion.
Motion and the interactions between different forms of it.
It's a big shift in perspective.
A fundamental one, and that's just the first part of the source.
Yeah, you're just getting started.
Part 2 delves into why we still have this strong feeling that time is real.
Right, because it certainly feels real.
It does, and how this motion theory might change how we understand some pretty complex scientific concepts.
Yeah, this is where it gets really interesting.
It does. So the source starts by addressing our subjective experience of time, that feeling that there's a past that's gone and a future yet to come.
Like time is this arrow moving in one direction.
Right, and they argue that this feeling is rooted in our memories of past motion and our ability to predict future motion.
So our brains are like these motion analysts,
Yeah, constantly processing and anticipating movement.
and that's what creates our sense of time.
Exactly. It's not about points on a timeline.
It's about remembered and anticipated movements.
Precisely. Like our brains are constantly creating this story of motion.
And we call that story time.
And we've evolved to be really good at recognizing patterns of motion, especially those that are crucial for our survival.
Like day and night, the seasons, our own heartbeat.
Yeah, those rhythmic cycles are deeply ingrained in us.
And that's why we created calendars and clocks.
Right, to track and organize those observed motions.
So our experience of time is really intertwined with how we perceive and organize motion.
It's all connected, yeah.
Okay, so that's the human side of things.
The subjective experience.
Yeah. But what about the really big and the really small? Like, what about quantum mechanics?
Yeah, that's a realm where our everyday intuitions about time tend to break down.
It's a very strange world down there.
It is, but the source suggests that even at the quantum level, the transitions between different quantum states happen through changes in motion states.
So it's still about motion, even at that incredibly tiny scale.
Exactly. It's not about time flowing, it's about things moving in specific ways.
And what about quantum uncertainty, that idea that particles can be in multiple states at once?
Yeah, that mind-bending concept.
How does motion fit into that?
Well, the source suggests that even uncertainty is related to how synchronized these underlying quantum motions are.
So more synchronized means less uncertainty.
In a way, yeah, it's like the more organized the motion, the more predictable the particle state.
And what about something like a photon, a particle of light?
Well, according to this theory, even a photon is a form of structured motion, adapting to its environment as it travels.
So even light itself is all about motion.
It's all about how things are moving and interacting.
Okay, so even in the weird world of quantum mechanics, motion seems to be the fundamental principle.
It seems to underpin everything.
And what about entropy? That idea that things tend to become more disordered over time.
And the arrow of time.
Yeah, that feeling that time moves in one direction, from past to future.
Traditionally, increasing entropy is seen as being driven by the forward flow of time.
Like time is pushing things towards disorder?
But the motion theory offers a different interpretation.
Okay, what does it say?
It says that increasing entropy isn't about time passing.
Right.
It's about the natural tendency for synchronized motion to become less synchronized.
Like things naturally spread out and become less organized?
Exactly. And we interpret that as the arrow of time.
So it's not time itself that has direction.
It's the way motion evolves.
It's like a sandcastle on the beach. It doesn't crumble because of time.
Right.
It crumbles because of the wind and the waves.
Exactly. It's the motion of the environment that breaks it down.
So we've been mistaking the effect for the cause.
It's a subtle but profound difference in how we think about it.
Okay, so entropy is really about the dispersal of motion.
And the arrow of time is just our interpretation of that process.
It's not time itself moving forward. It's motion becoming less ordered.
Precisely. And this leads us to some even more mind-bending concepts like time dilation.
Yeah, that's Einstein's theory of relativity, right?
Exactly, where time supposedly slows down at speeds close to the speed of light or in strong gravitational fields.
It's one of those things that's really hard to wrap your head around.
It is, but the motion theory offers an alternative explanation.
Okay, I'm ready. Tell me.
It says that extreme speeds don't actually slow down time.
Okay.
They cause an object's structured motion to become incredibly synchronized.
Like all the particles are moving together really tightly.
Yeah, like a perfectly choreographed dance.
And that affects time.
Well, in this state of high synchronization, the internal processes within the object slow down.
Like the vibrations of atoms.
Exactly. They evolve at a slower rate compared to a system that's less synchronized.
So it's not time itself slowing down, it's the physical processes.
The motion within the object is changing.
Like particles in accelerators that seem to live longer.
It's not that their time is different.
It's that their internal motion is slower.
Because of that high synchronization density,
It's like we've been describing the symptoms instead of the cause.
we've been using the language of time to describe changes in motion.
And that's led to some misunderstandings.
Potentially, yeah.
And the source also applies this to GPS satellites.
Yeah, which need those relativistic corrections to work accurately.
We're told it's because time flows differently for them.
Right, because of their speed and the weaker gravity.
But the motion theory says it's not about time warping.
It's about the satellites and the Earth being in differently synchronized states of motion.
And that affects their internal clocks.
Exactly. The corrections aren't for time discrepancies.
It's for differences in the rate of their internal motion.
It's all about how things are moving.
Okay, so GPS is another example where motion might be the underlying explanation.
And then there are black holes.
The ultimate time benders.
Yeah, where gravity is so strong it supposedly slows time down dramatically.
Some even say time stops at the event horizon.
Yeah, it's a wild concept.
But what does the motion theory say about black holes?
It says they're not about time warping. They're about extreme motion synchronization.
Okay, so how does that work?
When matter gets close to a black hole, its internal motions get slowed down drastically.
Because of the black hole's intense gravity.
Right, because of the black hole's overwhelming tendency towards synchronization.
So it's like the black hole forces everything to move together.
Yeah, it's like a cosmic dance floor where everyone has to follow the same beat.
And that's why things seem to slow down or freeze near a black hole.
It's not time itself slowing down, it's the matter's motion becoming incredibly sluggish.
Because of this intense synchronization field.
Exactly. It's a whole different way of understanding black holes.
So instead of time being distorted, it's motion being controlled.
And this motion theory really challenges our fundamental understanding of physics.
It's a lot to take in.
It is. It makes you question everything you thought you knew.
And the source takes it even further, to its logical extreme.
They imagine a universe where all motion stops.
Everything freezes, completely still.
And they ask, what would be left?
It's a good question.
And according to the theory, reality as we know it would cease to exist.
Because reality is fundamentally motion.
If nothing's moving, there's no change, no events, no experience.
Time becomes meaningless in a universe without motion.
Exactly. It just wouldn't have any purpose.
So the source is saying that what physics calls time is really just a record of motion sequences.
It's a way to track and organize change.
And the universe itself doesn't need time.
It operates purely through motion and interactions between different forms of motion.
So time is just something we created.
It's a human concept.
To help us understand and predict change.
Exactly. It's a tool we invented.
So the big takeaway here is that the universe doesn't actually need time to function.
It's all just motion, constantly interacting and evolving.
Time is just our way of making sense of that.
A useful tool, but not a fundamental ingredient.
And that's a pretty radical idea.
It challenges everything we thought we knew about the universe.
It really makes you wonder, if time isn't what we think it is, what else might we be misunderstanding?
It opens up a whole new world of questions.
That what about cause and effect?
Yeah, are those just sequences of motion and energy transfer?
And what about consciousness?
Could that be understood as a complex form of structured motion in our brains?
It's mind-blowing to think about.
It is, and it shows how much we still have to learn.
And I encourage everyone listening, take some time to think about this motion theory.
Yeah, look at the world around you.
See the motion in everything.
The way things move and interact.
And maybe you'll start to see the world in a whole new light.
It's a different way of experiencing reality.
This has been an incredible deep dive.
A real head-scratcher.
We've challenged some fundamental assumptions about the universe.
And hopefully sparked some new ideas.
Thanks for joining us on this journey.
And we'll see you next time for another exploration.
Where we'll dive deep into something new.
And challenge your thinking once again.
Until then, keep those brains buzzing.
And keep exploring the mysteries of the universe.
See ya.